Hello and welcome to August's episode of the Kielder Observatory podcast. I'm Ian Brannan, and joining me this month, as always, is Director of Astronomy Dan Pye. We'll be having a look at some things coming up at Kielder Observatory over the coming few weeks, as well as a few things to look out for in the night sky, where you should be pointing your telescope, if you have one, or indeed binoculars. And our special guest this month is one of the faces of astronomy, I guess you'd say, on TV, Chris Lintott, one of the presenters of the BBC's Sky at Night.
The Sky at Night used to be every lunar month, so it was timed to coincide with the new moon, because it was assumed by Patrick in the 50s that any serious amateur astronomer would be looking at the moon. And so the only time you could broadcast an evening programme for astronomers is during new moon, because then they'll be able to come in and watch Patrick instead of being out making observations.
So we'll be having a good chat with Chris Lintott very soon about life as one of the faces of astronomy, hosting that iconic programme, and how you can get involved with one of his other projects, which is called Zooniverse, where you can look at some images taken in space by some of the satellites that are out there and help identify what we can see, so you can actually join in some actual space research from wherever you are. More about that to come in a few moments. But first of all, let's catch up with Dan and find out what's happening at Kielder Observatory and in the night sky as a whole. Because I guess if you, like me, you've got one of these apps on your phone that tells you what's going on with the aurora, because we're heading into aurora time of year now. You've maybe had a few pings lately saying, red alert, aurora may well be visible, can you see it? And indeed, we have had some sightings of the aurora at Kielder Observatory over the past few weeks or so, through the course of August. And that's great news, but nice to see some aurora coming back, Dan.
It is, yeah. When we get closer to the equinox, of course, we get to see more auroras. And it's something that we don't really quite understand as well. Why do we get more auroras around the equinoxes? And I'm sure there's some people who have some interesting theories around it, but I think the general consensus is that we're not 100% sure. But we are reaching the equinox in September 23rd is when that lands, and we've had some really intense aurora actually this week when we're recording this. Last night I was frantically trying to image the aurora, and it was a clear night. And further down in Northumberland on Hadrian's Wall, there were some people who managed to take some really great photos of the aurora. I think I just wasn't there at the right time taking the photographs, because it can be quite elusive. It's a thing that if it does happen, it might just happen for a 15-minute window for us here in the northeast. It might stay around for the entire night, and so it is quite an elusive, difficult thing to see and to capture. But it is kicking around. It is there, and so it's certainly worth setting up the notifications and downloading the apps in order to be able to ping you when there may be a potential chance of the aurora. And of course, that's Aurora Watch UK app, which you can download for your phone, and the Glendale Sky Auroras website as well, which is aurora-alerts.org is the website for Glendale Sky, and they've got some really great information on there which you can digest at your own leisure. And there's also observations which help you. If you get a ping from Aurora Watch UK, you can go, well, are we seeing it near where I am? Go to Glendale Sky Auroras, and if somebody said they've seen it near you, get outside and start looking for it in the north direction. See if you can see some aurora.
Yeah, it could well happen. You might be seeing a lot about it in the papers as well, because they're getting excited about the aurora and printing big graphics of the area that it might be visible from. Of course, you need ideally dark skies for this. If you are in a built-up area, you might struggle a little bit, but I guess the best advice is to have a chance of seeing it. It's look towards the north, isn't it? But also get yourself into the darkest possible place that you can.
Yeah, try and get a really nice, clean northern horizon, free from as much light pollution as possible. A good place to do that, actually, is going out to the beach. If you've got a north-facing view, then you can get a really nice view of the northern sky, and a lot of it, because there's no hills and stuff in the way. And, of course, no light pollution out towards the sea as well. So good opportunity to see it at beaches, big hills, places like that. Good clean view of the north is what you want, and ideally a camera that can take a photograph for a couple of seconds, maybe 5 to 10 seconds, depending on what kind of lens you're using. See if you can get some colour creeping through. If you've got some distinct green arc or maybe some pillars of light, then there's some aurora for you. Just keep taking photos and see what you get. See if it develops, see if it changes.
Okay, so keep your eyes peeled and happy hunting. And 23rd of September is likely to be the peak, maybe, but you never know when it's going to happen. And those apps will give you a good indication of if the conditions are indeed right. But keep your eye out on that. Other stuff to look out for then at this time of year. We're starting to see more planets now. I notice we're getting Saturn in the sky, certainly. Jupiter thereabouts as well. So we're heading into that period of year where it's a good hunting ground for planets for astronomy with either the naked eye or with a telescope.
Yeah, it is. You can confidently see all of the planets at the moment throughout the course of the night if you wanted to with your big telescope. You'll need a telescope to do that. My dog's having a disagreement with somebody outside right now by the sounds of things.
Not the planets.
but the planets are visible throughout much of the night now, starting with Saturn rising. As it gets dark, you may get... Venus is up just after dusk, I think. Check your Stellarium maps and places like that, and it'll show you the right direction in which to look. And apps like that, many of them are free to download and will guide you in the right direction at the right time of night to see these things. But certainly Jupiter, Saturn, and Mars are very, very easy to see. They're very bright and dominate the sky. Later on in the evening, last night, we got some great views of Mars, a good hand and a half's width above the horizon at 11 o'clock at night. And Jupiter is very high at the moment. And if you actually get to a dark sky park or somewhere that's free from more light pollution, I think you can start to see colour difference with Jupiter. I think it looks a different colour. It looks distinctly different as Jupiter. A beautiful thing just to see visibly with the naked eye. So do keep an eye out for that.
Yeah, a couple of things to look out for. And also, what else have we got going on in the night sky this time of year over the next month, heading through into September, middle parts of September? What are the things that perhaps people should be looking out for?
Well, we'll see the return of the Pleiades, of course. Pleiades starts to get higher at this time of year, and then that means that later on in the night you're getting Orion rising as well. It always surprises me that Orion comes back around so quickly. In the back end of August into September, in the middle of the night, we get Orion rising, which is an incredible wintertime constellation. And even just to see the Pleiades is a really nice thing as well. That's a great non-telescope visual target to take a look out for. But there is some interesting things happening away from just the night sky in terms of science missions as well. On 29th of August, it's scheduled that the Artemis program is doing a test flight with a test dummy around the moon. So it'll be flying around the moon and coming back again. And this is, of course, starting our Artemis mission, which will return people to the moon by 2030, which is incredibly exciting. So that'll be a very significant launch on the 29th if it happens then, or if it gets scrubbed. I'm hoping that it gets scrubbed for a couple of weeks because I'll be there to see it if it does, because I'm visiting Kennedy Space Center in September. So that's an exciting thing that's happening as well. Just for me, though. Yeah. But if there is a rocket launch, I'll share it, of course, on social media, so you'll see that.
Well, You've got your phone in your pocket. That's all the recording device you need. You can bring us the big NASA exclusive live from Kennedy Space Center next month.
Certainly do that.
It's a challenge. Yeah. And with the moon, they're also looking at where to land. You know, man's going to the moon in, I think, 2025, and the south pole of the moon is where they're planning to land man this time round. Yeah,
they are, and it's really good that we can get these really high resolution images of the moon now, because of course the first time we went to the moon we didn't really have high resolution images. A lot of the mapping of the moon was done from a ground level, and we when we started to get closer and closer and closer to the moon, we realised that actually there was a lot more of a rough terrain than was anticipated, and that was a challenge which Neil Armstrong and Buzz Aldrin had when they were landing on the moon, is that the area that they were scheduled to land in, or the area that they were supposed to land in, was a little bit rougher than they'd anticipated. So they had to change that decision, and they had very limited fuel. So it's really, really, really crucial to get that decision made as early as possible as to where's the best or most appropriate location to land on the moon.
As far as Kielder Observatory is concerned, the sessions are running as normal now, after a bit of disruption, of course, earlier in the year with the pandemic, of course. But things now long since pretty much back to normal, and plenty of sessions for people to get themselves involved in over the course of the next month or two.
Yeah, for sure. And it's actually moving into our busiest time of year now. When we start to get into the winter time, that's the time where we are, of course, busiest, because it is the best time of year for stargazing. It is also a very cold time of year, though. So if you are planning your trip to the observatory, last night it was cold. We were really contemplating putting a fire on last night, and in fact, Ellie said if it's as cold as it was last night tonight, and we're out stargazing, then she's going to crack a fire. It's going to be the first fire of the season. Is that? So do wrap up warm. But yes, we are starting to increase capacity as well, back to normal capacity now, there or thereabouts. And operations are moving back into the regular pre-COVID kind of times of operation. So it's nice. It's nice to experience the observatory as it once was, instead of during the COVID restrictions. So that's quite nice. And of course, we are still being incredibly careful. We sanitize everything very carefully, and if we can social distance, or at least if we can create spaces where we can keep in ventilation where we can as well, we are still being incredibly cautious, because we are a very small team. And if we have a number of members of staff off with COVID, then it can really impact on our delivery of events, and it could even result in not being able to deliver events. So which is why we've kept our COVID restrictions for such a long time so strictly. So we are still taking it incredibly carefully.
And through the course of the school holidays, of course, you've had plenty of kids' sessions as well. I mean, how have they been going? Because they're always quite fun, aren't they? Something a bit different.
They are, and they've been going very, very well. And we trialled some new style kids events a few weeks ago, our Light Year Academy, which will be returning next year. We're planning the calendar for next year, and we've practically signed off what we're doing next year now. So during June time, we'll be running the Light Year Academy a little bit later at night as well. We'll be running it from 7 till 10, and we've got some other great events that we're going to add on to the calendar next year as well, and some really, really interesting products that we're working on, and some really interesting experiences that we're working on for the next calendar year as well, and improving the stuff that we've got going on in the observatory. And all of that has really been learnt from the stuff that we've done this year and in previous years. We're really starting to analyse our place and what we do, and the service that we offer, and the feedback that we get, and all of that stuff is being considered very heavily at the moment, and that will sculpt how we look in the future for sure.
Okay, so there's a few things, and of course the sessions are all on sale now. You can book them on the website. And how far in advance can you book? I think it's quite a way, isn't it?
Yeah, well, actually, in a couple of weeks' time, you'll be able to book all the way through till September next year. At the moment, up till May next year is where you can book up to. But yeah, in a couple of weeks' time, we'll have up to September 23 on there as well.
Okay, so you can start planning for the school holidays next year if you want to get really ahead of the game. Look out for those in the next few weeks as well, for the kids' sessions, and a whole lot more besides too. All online at kielderobservatory.org. Finally, before we speak to Chris Lintott, our guest this week, do you have a pie in the sky moment? A little extra challenge for those with the right telescope or binoculars. Something different to search for in the night sky.
Okay, cool. So a popular target for the one that we have at the observatory is a one called the Dragonfly Cluster, and it's a great cluster to take a look at with a telescope. I think it looks less like a dragonfly, more like either a bat or an owl. And it's got two stars, which are quite bright. And then it has these wings, which are outstretched. And you can kind of trace a body in the shape of this cluster. It's an open cluster, a beautiful open cluster. And you'd certainly get it with a 6-inch telescope quite easily. It's about 5,500 light years away as well. So it's quite a nice, cool object to take a look at, and a few different colours of stars in it as well. So if you get to a really dark sky area and you had an 8-inch telescope or a 10-inch telescope, then you'd probably start to resolve some really nice colour in those stars as well. But see what you think it looks like. Does it look like a dragonfly to you? Does it look like an owl? Or does it look like a creepy bat with googly eyes?
That's one to look out for. Let us know how you get on. Pie in the Sky for this month. Dan Pye, Director of Astronomy. And right now, we're ready to welcome our guest for this month, Chris Lintott from the BBC's Sky at Night. Welcome to the Kielder Observatory podcast, and time for our special guest this month, a man who is now one of the faces of one of the longest-running TV programmes in the world. The Sky at Night from the BBC has been on our screen since 1957 and so has been on TV now for 65 years, educating astronomers, both novices and those with a greater understanding of the night sky in what we can see and what's going on in space. And of course, at one point, it was the only place probably where we would learn new information about the developments in astronomy. Professor Chris Lintott is his name, and you will have seen him if you've been watching Sky at Night over the past few years. He's also involved in another project called Galaxy Zoo, inviting all of us to get involved with some astronomy and describe some of the images we're seeing from the night sky that have been taken by telescopes looking into distant galaxies and asking our opinion of what it is that we're seeing. And I was doing that this morning, and I was helping to further the project in my own small way. But he's also an author as well and has worked alongside the likes of Brian May. And of course, Brian Cox is a fan of his work as well. And he's here to talk all about space with us right now on the Kielder Observatory podcast. And our very great pleasure to welcome Professor Chris Lintott to the Kielder Observatory podcast.
It's good to be here. Thanks for having me, and thank you for classifying some galaxies and adding to our stock of knowledge about the universe. It's a good start to the morning, I think. If you have a cup of coffee first thing and view a few galaxies that no one's seen before, I think that's a nice start to the day.
It was really interesting because I was looking at it, and I was when I first went to the website, I was wondering how much knowledge and what equipment I might need or anything like that, and to have the images there, and you've just got to describe them, and everything's very, very self-explanatory. You've got these options: does it look like this, or does it look like that? Can you see it from side on, or is it front on? And a great way for anyone to do a little bit of help you with your research, of course, into the deeper universe. See these galaxies that have never been seen before, and try and work on it, because there's a lot of stars, a lot of galaxies to work through.
Yeah, it sort of came at this idea backwards. Maybe we could zoom out a bit, because I grew up as I suspect lots of your listeners did, as a kid with a telescope looking at the night sky, and partly that was for fun. I liked getting to know the sky, as I still do, go out and stare at Saturn for a bit, or look at the Orion Nebula or something like that. But I definitely wanted to make a discovery. I'd spent a lot of time thinking about what I wanted to discover, and decided that I think a comet appeals best, because comets are named after the discoverer. So Comet Lintott, I actually still think has got a pretty good ring to it. And there's this long tradition, of course, of amateur astronomers, of people with back garden telescopes making discoveries and doing science. And that was part of what got me hooked on the idea of astronomy as a hobby in the first place when I was 11 or 12 years old. But it turned out that it's quite difficult to find a comet. It's particularly quite difficult to find a comet if you've got a 6-inch reflector in suburban South Devon, and you have to go to bed on school nights. And so the days when, the great amateur astronomers like Alcock, who used to scan the whole sky with binoculars every night and found comets by using his memory, had gone. And most of the people doing amateur astronomy with a purpose are using quite sophisticated equipment, or at least they're a lot more trained and specialists than I am. And so I sort of went off to university thinking that the age of being able to easily contribute to science had gone, and that astronomy was now something done by professionals, by big organisations, by big surveys. But it turns out that that's not true. What happened in the meantime was that the amount of data that we have about the universe has increased. So in the 50s, 60s, 70s, every image taken by every professional telescope could more or less be pored over by professional astronomers. That's simply not true anymore. And so Galaxy Zoo, which started 15 years ago this summer, which seems like an awfully long time now, but came from this fact that we had images originally of 1 million galaxies, and we didn't have enough people to look at them. And so we realized that by putting them online, we could harness the enthusiasm and excitement that lots of us feel about the cosmos. But we can also go back to the idea that you could casually discover something over a cup of coffee. And so I see these two things as very similar. Sort of the grand tradition of observational amateur astronomy, with people monitoring storms on Jupiter, discovering supernovae, and taking deep sky photos and so on. And this sort of online process like Galaxy Zoo, where people are classifying galaxies, are finding planets, and are keeping an eye on the Milky Way and various other things in between. But both are united by, you need to be interested in the cosmos, be interested in finding things out, and have the enthusiasm to spend a few minutes learning and then clicking on some buttons for us.
Yeah, zooniverse.org is the place to go, and you can get involved in this, and you'll get on there, you'll see it all straight away. So it's fantastic. And so, where do the images actually originally come from? Where's the stash of images from? And do multiple people classify the same image so that you get the right answer?
Yeah, they do. So that's why I'm told and I kind of understand this. It can be a bit anxiety-inducing.
I'm thinking, have I got it right?
No one's ever seen this galaxy before. Yeah, exactly. The responsibility of classifying this galaxy for humankind is a shared one. Yeah. And so that's actually an interesting thing. We have lots of people look at each image, and that gives us more information than if I have one person look at every image. Then they're going to make mistakes. We had at the start of the project, there was a PhD student called Kevin Sherwinski who looked at 50,000 galaxies. And in those 50,000, as he spent a couple of weeks doing nothing but going, that's a spiral galaxy, that's an elliptical, that's a spiral, he will have made some mistakes. But if I have 20 people look at the same galaxy, no 20 people are going to hit the wrong button by accident. So the mistakes get evened out. But we also get information, because it turns out to be useful to know that, say, 20 out of 20 people say this is a spiral galaxy versus 17 out of 20 people say it's a spiral galaxy. It says something about how reliable that classification is. And that turns out to be useful for all sorts of things. But yes, there was another part to your question. Oh, where did the galaxies come from? Yes. Yeah. At the minute in Galaxy Zoo, the galaxies you looked at this morning were from a survey called Decals, which is a deep survey with a 4-meter telescope of the southern sky. So we started off doing the northern sky with a survey called Sloan. We've done Hubble Space Telescope images looking deeper into the universe. We're now trying to fill in the southern sky both because we want to get more galaxies classified. But also there are interestingly sort of medium rare classes of galaxy that we just need more of. So we started with 1 million galaxies. That sounds like a lot, but by the time you decide that you want to study, barred spirals with small bulges which are still forming stars and which have a mass about the same as the Milky Way, you could start with 1 million galaxies and end up with 100, which isn't always enough to do what we want to do. And so lumping in the southern sky doubles our number, hopefully, of each of these rare type of galaxies. So we're currently on the southern sky. The next plan, which we're working on now, is to use data from the from JWST, the new space telescope that NASA, ESA, and Canada have launched. And people will have seen the images from JWST, I'm sure. But there are deep surveys of the universe going on with that telescope where we're going to need to classify galaxies. And it's becoming apparent that we're going to need help to do that. So even from this most exciting, most shiny new observatory, we need people's help to sort through the data. So hopefully maybe by the end of the year, we'll be showing people images from the JWST that no one's seen before.
Now, you mentioned there about, youngsters growing up and being fascinated with the universe. You surely were that person not so long ago. And when you were doing that, you would have been watching the sky at night. And that was obviously one of the only places to get information at that time, pre-internet, really more than 1 or 2 TV channels, I guess. And so for you to now be that guy who's on the sky at night, and of course you worked alongside Sir Patrick Moore for a time as well. I mean, that must have been like living your childhood dreams.
It did feel a bit like stepping through the camera, or stepping through the TV screen, not least because Patrick was the same off-camera as he is on. Incredibly enthusiastic, talks very fast, knows knew a hell of a lot about everything, really. It was amazing. It was a series of completely lucky coincidences that meant that I ended up in the right place to start that job, working alongside Patrick. And I got to do something that no one gets to do now, which is I got to be terrible at television for a while. So we've just been going back through the archive. So we're doing a program on astrophotography, which comes out. That'll be September's program. And we've gone back to find some early Pete Lawrence appearances. He's our digital photography guru. I'm sure many of your listeners know Pete, but we've gone back to find old Pete. But there's young Chris in there as well. And it's very clear. It's sort of Sky at Night's always got this sort of, we don't really have a budget. It's just some people talking about space charm. But I do wish somebody had told me to iron my shirt a little earlier on. But no, it was great. I think there are two things that are brilliant about Sky at Night. One is it's always tried from Patrick's first program to cater for everyone. So I think it's the only program where, let's say we're doing a program about Mars. The program will consist of various things, but we will at some point say Mars is the fourth planet from the sun. It's the red one. It's a desert planet with ice caps. You can see it in a telescope. Look, it's the red thing in the sky. That very basic, straightforward information. But we'll also end up saying the discovery of perchlorate in this particular region makes the surface chemistry interestingly hostile to life, which raises questions about the Viking experiments. And we can go into this detail as well, so that anyone watching the Sky at Night, no matter what you know, will learn something. And we do that by talking, of course, to the world's great experts. So I get this masterclass every month in a completely different topic. And that's enormous fun. And then the second thing that's unique about the Sky at Night is that it's this weird monthly program. There aren't many monthly programs on television. And in fact, it was even weirder in the past. I was talking to somebody online just this week and pointed out to them that the Sky at Night used to be every lunar month. So it was timed to coincide with the new moon, because it was assumed by Patrick in the 50s that any serious amateur astronomer would be looking at the moon. And so the only time you could broadcast an evening program for astronomers is during new moon, because then they'll be able to come in and watch Patrick instead of being out making observations. You could have tied it to the weather instead, I suppose. But in Patrick's words, sometime in the 1990s, the BBC lost track of the moon, and we moved this monthly program. But what that does, it does strange things. What it means is that we can move a story on, and we get to know people, and we get to know missions and bits of research as they go. So our August program, which if people haven't seen, they really should go and watch on iPlayer, because it's really good, even if I do say so myself, is about JWST. And about a month ago, we had the first images, and there was loads of news coverage of these 4 or 5 spectacular images that came as a press release, as a big press conference with lots of hoo-ha from the space agencies. But we're there a month later. We can't do the news story because everyone's already heard it. So instead, we went and talked to a series of scientists who are using data now to find new things and have got their hands on the telescope. And that's not a news story. Hannah Wakeford in Bristol gets data is exciting for Hannah, really exciting for Hannah, as you'll know if you've seen the show. But it's not a news story, but it's an important part of what's going on. And I think our viewers like hearing those bits. It's not just covering the landing of a rover on Mars. It's turning up 6 months later to say, how's it going? Have you found anything? And it's not just talking to Jane Greaves in Cardiff when she thinks she's found phosphine and possibly aliens on Venus. It's checking in a year later to see whether that result stood up and what the new observations are telling us. So I really like the fact we get to do these ongoing stories.
That's really interesting, that as well, because there's so many times that we hear things that just disappear into the ether. We hear this wonderful headline, and then a couple of months later, it's old news and nobody's followed it up. So it's a great thing to have that follow on, like you say.
Yeah, it's almost. I think Patrick would talk about this as well, but his example was always the Apollo program, of course, because although the Sky Night didn't cover a lot of Apollo, he did, and the BBC did, and he was very proud of the fact that they were still there for Apollos 14, 15, and 16, as well as, the first, the last, and the disaster. And so, I think that sense of following a long story is important. One thing I really want to do, I haven't sold this to the rest of the team yet, but I think we urgently need to do a program about the Hubble Space Telescope, because it's still there and it's still working. And I think we've given the impression in lots of the JWST stuff that Hubble's dead and that we don't need it anymore, and maybe we've sold it off or something. Some astronomical society are now using it for taking pretty pictures or something, but it's busier than ever. So I quite want to do a program. It's a bit perverse, but I'd love to do a program which is people who've chosen not to use JWST talking about why Hubble is still awesome. I think that would be fun.
That would be great, because we actually do get quite a lot of questions at the observatory about Hubble, about how it's been replaced and that's it, it's the end of Hubble because JWST's here and stuff. So it's certainly a thing which is in the forefront of people's minds. They're thinking that Hubble is dead and gone, and that's sad, because of course there is incredible astronomy still happening with Hubble. Yeah,
indeed. Although on the other hand, I have just written a column, I think it's in the issue that's out now for Sky at Night magazine, just pointing out that I've been wrong about Hubble and JWST since the beginning, because I've always worried about, and I think I thought it made me sound kind of intelligent to have this point of view, but I would tell people not to get their hopes up about JWST because it was always billed as Hubble's successor. One of the things Hubble does, as you know, is take spectacular images. I was just looking at the old. Everyone can think of the 3 or 4 Hubble images, the Pillars of Creation, the Whirlpool Galaxy, Eta Carini, whatever it is for you. People have this gallery of Hubble images in their heads. And I used to very cleverly tell people that we need to be careful because JWST is an infrared telescope, longer wavelength. When you go to a longer wavelength, you get blurrier images. So, JWST will do great science, I would say, but the images are not going to be spectacular. So it turns out I'm wrong. And the reason I was wrong is because I was thinking about the infrared. But of course, the other thing, the bigger the telescope mirror, the better the images, the sharper the images. And JWST is a 6-meter mirror compared to Hubble's 2.2. Actually 6.5, isn't it? And that's why they went to all this trouble of folding up the mirror and fitting it into the rocket so that it could unfold when it launched. But it turns out that blows the difference in wavelength out of the water, and we're getting images of the infrared sky that look like nothing we've seen before. And it's great fun watching people see their favourite objects in a new light.
And what have you taken from those first images that have come out so far? Because only a few, of course, yet, and we're going to learn a whole lot more over time. But what have you taken from those first little bits?
I think the diversity of galaxies is interesting. They're often in the foreground, so there's been a lot of attention. One of the things people have been rushing to do is try and find the most distant galaxies. One of the reasons that you've looked at JWST is to find very distant galaxies. But we're in a slightly odd situation in a minute in that several groups have different suggestions as to which might be the most distant galaxies, and none of them agree with each other. And the odds are lots of those are local. So understanding the calibration makes this quite difficult. So it's like getting a new scope and playing with it for the first. In fact, that's exactly what we've done, right? Your best photograph is not going to be your first one. And so there's a lot of work to do for that. But in the foreground of lots of those images, there's an awful lot of distorted galaxies. In the infrared, you pick out where the star formation is happening. And so we're seeing, I think, much more disrupted galaxies than I expected. And one of the reasons we're going to put those images into Galaxy Zoo is because we want to understand whether that's just me getting distracted or whether there really are, in the kind of redshift range that we're talking about, so the universe as it was 3, 4, 5 billion years ago, what we knew was that there was a peak of star formation activity back then, but I don't think we'd quite realised it was driven by this disruption, maybe mergers of galaxies. So that from a science point of view, I think that's really interesting. Mainly, I'm enjoying the fact lots of the data is public. There are citizen scientists, I guess you could call them, but there's some amateur hobbyists who are grabbing the data from the archive and spending their time making beautiful images. So rather than trying to tease out the science, they're combining images from different cameras and so on. And some of that work looks absolutely incredible. The best image I've seen of Jupiter from JWST comes from some of that work. And so I think it's also confirming how important it is to share this data, to make it open, to let everyone in the world have a play with it.
Yeah, that's really interesting as well, because that's another question that we get. I've got a lot of questions at the observatory, but this is another thing that people often bring up, is that how is the data shared, and is it that you can go to a central place? Do people talk to each other? And we always tell them that the data is usually accessible to everybody, and anybody can get involved in that and take what they want to take from that. And I think that's the beautiful thing about science in all, is that it is there for everybody to take their learnings from it, and that just opens up so many new interesting avenues.
I think that's right. I think you could see this from the Mars Exploration Group have always done a good job of this, right back to Spirit and Opportunity, where they made the decision to release images on the web as soon as they hit the ground. So I still have a Twitter bot that tells me when Curiosity or Perseverance send a new image to Earth. And if I happen to be on Twitter, not that and I'm on Twitter a lot, if I'm honest, but if I happen to have the app open, I'm probably seeing those images from this spacecraft, from this robot on the surface of Mars, before the people who built it, because they've got, lives and jobs and things. But to sit there and get the first image, it's often, a blurry calibration image, or it's a shot of the rover's own wheels because they're doing some engineering or whatever. Just occasionally you get something spectacular. But the fact that that's just shared is great. And they've always worked with hobbyists and citizen scientists to make images. Another example is the Juno space probe, which is swinging around Jupiter on this long orbit that takes it down every couple of months. It goes over the surface of the clouds, just a few hundred or maybe a few thousand kilometers above the surface. We get these detailed images of Jupiter's atmosphere, which, incidentally, we need your help to classify. There's a Zooniverse project on Jupiter, looking at the storms of Jupiter, which everyone should go and have a look at. The images are stunning. But that gives you the close-up view, the context, the sort of being able to put what the spacecraft is seeing in the context of the whole planet. That's done with a worldwide network of amateur astronomers, of people with small telescopes, webcams, image processing software, who work together to provide a map of Jupiter to the project scientists, and who suggest particular images that the Juno cam should take. So I think wherever you look, there are these places where it's not just that sharing data is sort of some worthy thing. Sharing data actually makes the science better, as well as meaning more of us could get our hands on it. And that's pretty exciting.
The Sky at Night, as you mentioned, is a show that I think fascinates everybody, those who've got a great knowledge of space and those who are just starting to get interested. I'm at the stage with my daughter where she's just starting to get into space, and she knows all of the planets and all of the dwarf planets off by heart. She's 5. She's learnt this off YouTube, and she's sort of furthering her own knowledge by watching kids' videos about space on YouTube. So my next question actually comes from a 5-year-old, Chris. So I hope you're ready for this.
Before you get there, all the most difficult questions I've ever been asked come from 5-year-olds. So I'm sort of on the edge of my seat, but I will do my best. Go for it. Shoot.
Okay, stand by. Now, her question is, it's about black holes, and she says, which planet is the closest to a black hole? And that's, which planet currently is orbiting or nearest to a black hole, in danger of slipping into a black hole, I think is what she's meaning. Do you have an answer to that?
It's a good question. So, well, in theory, we could have a planet in orbit around a black hole, which is kind of fun. So one of my ambitions in life is I want to found this. This is a terrible answer for a 5-year-old, but as an aside, I want to found the Society for the Rehabilitation of Black Holes, because black holes have this really scary reputation, right? It's impossible to talk about black holes without you find yourself slipping into saying things like lurking at the center of our galaxy, or the black hole devoured a star, and I think we give the impression they're like cosmic vacuum cleaners that you might, but they're just, you can orbit a black hole just as you can orbit the sun. Just don't get too close, right? But you could happily be out here in orbit around a black hole. And we know that there are planets around pulsars, which are produced when stars bigger than the sun die. And some black holes are produced by stars even bigger than that dying. So it's possible that some planets might survive and be happily in orbit around a black hole. So that's one way of saying we don't know yet, because my guess is somewhere in the galaxy there's a planet orbiting a black hole. Whether we'd find that or not might be quite tricky. I don't think we know of any planets that are particularly close to black holes right now. We know there's a black hole at the centre of our galaxy, and we think that there are lots of planets near the centre of our galaxy. So if I had to pick one, I'd pick one of those planets that seem to lurk much closer. See, I'm doing lurking it. That seem to live much closer to the centre of the galaxy. But my guess is that's the wrong answer because we haven't found all the planets yet.
That's a very good answer. Very good answer. But but that's how it all starts, I guess. For many people at a young age, the fascination with the universe, and as you're saying there, that fascination, it doesn't have to necessarily be your career, but now with things like you're saying, with the sort of social ways that people can get involved with research, such as the things that you're doing with the Zooniverse, it's all ways that people can really contribute and be involved, even if you're not a professor.
Yeah, I think it's about, for me, one of the important things about Zooniverse is that you can't be on our site for more than a couple of minutes without realising that science isn't finished yet. And I think a lot of people get through school thinking that science, or being taught that science is a set of received facts, that there are textbooks where everything we know about the universe is written down. And if you read enough of them, then you'll know everything about the universe. But actually, science is ongoing, right? We have more questions than answers, and that continues to be the case. In fact, a good scientific idea will create more questions than answers. And so I think by participating in science, whether it's trying to find a planet or counting penguins or whatever it is on Zooniverse, I think you couldn't possibly go away with the idea that we're done. If we don't know how many penguins there are in Antarctica, if we don't know how many dwarf planets there are, if we don't know whether there's life on Mars, we can't possibly be done. And those are all active questions. So I think giving people a chance to experience science as an ongoing thing. And I think that going back to when I was a kid looking up at the night sky, I think it was that sense of being just on the edge of answers that I found really exciting. Being able to say which of these stars have planets and think that would be something we would know in our lifetimes is really exciting. Or, to look at Mars and ask the question about whether it's ever had life and know that people are building probes now to go and test that, or to move our understanding on is I think, the core fascination of it. Yeah, I want people to realise that you can follow this just if you follow a sports team, you can follow science, right? It's the same process of reading slightly dense, slightly strange articles about esoteric things, but picking your niche and getting into it.
I think it's really good that people get to see the rigorous nature of discovery as well, because there is occasionally whereby people can be quite sceptical in the sense of, how do you know there's a planet going around it? And we say, we watch these shadows, and people assume that we've seen it once and go, it's a planet. But actually, it's that we've seen it a few times, or that it's been through many, many eyes, and all of the research is very heavily looked at and gone through and analysed. It's not just our quick guess on an observation. It's we've actually gone through these incredibly long processes, and it's had many eyes on it to come up with this.
I think that's right. I think it's also important that people realise that science can be wrong, or scientists can be wrong. I think we spend a lot of time. I spend a lot of time, I think, in discussions with people who are worried about the effects of the latest press release from the university of wherever that says astronomer solves dark matter mystery, and then it turns out they've got an idea or a theory, and that's been published, but obviously we need to do more work or carry out the process that you talked about. I think it's okay to be wrong in public. I think we need to show all the aspects of science, from the raw data to the first thoughts to the crazy ideas to the testing and so on. Because then when people encounter a new idea, like in the middle of a pandemic or something like that, they have a better sense of the status of a statement about whether masks are worth wearing or whether you should get vaccinated or whatever. You need to have tested those muscles in thinking about the universe. And so that's important. So I think the more open we can be, the better. And that means being relaxed about the fact we're going to be wrong in public. I'm wrong a lot of the time. I've nearly disproved my entire thesis. I think if I finish that process, I disappear. But it's not very clear. Maybe I just go back to being 20. But science is a process of being wrong a lot of the time. And we need to tell people that as well, and have people enjoy that. There's a lovely Bill Bryson line. I forget which book it's from, but he meets somebody on a ferry somewhere and gets talking to them, and they turn out to be a nuclear physicist. And he says something like, he discovers the guy was trying to find out, I think, how uranium decays or something like that. And Bryson says, well, did you? And he just says, he smiles a scientist's smile and says, we found out precisely how it doesn't decay. And I think there's an awful lot of finding out exactly how the universe doesn't work. And that's progress too. It's same in Zooniverse, right? So some of our projects, Galaxy Zoo is about classification. It's about sorting through galaxies. Some of the projects we've had projects looking for supernovae, where people, Planet Hunters project that I've mentioned a few times, where people are trying to make a discovery, the equivalent of searching for Comet Lintott. But you have to realize that if you go on Planet Hunters this morning, we'll show you data from stars from NASA's TESS mission. And the odds are, if you spend 5 minutes over your morning coffee, you're not going to see a planet. But what you're going to do is tell us that there isn't a planet in 5 or 6 sets of data. And that's as big a contribution as being the person who gets lucky and says, there's something there. And so it is this collective effort. If we're wrong enough, often enough, then occasionally we get to be right. And I think that's one of the things that if you just follow mainstream reporting in the papers or online about science, I think it's very difficult to understand that, because no one puts out a press release when they're wrong. Maybe we should. Lintott wrong again. Oxford not shocked. But yeah, that sense of the joy of I've got an idea, let's try it. Is part of the fun.
I think there's something liberating as well in saying that, this is what we know now, but that could change, because there's many times people who say, well, the periodic table, okay, so that's it, yeah, and you're like, well, that's what we know now. Is what I always refer to as, and I always I try and avoid trying to go down a route of, yes, this is a definite, this is exactly what's happening, this is exactly what that is, because I always like to leave that little bit of flex room, that little bit of uncertainty, and I think that's what keeps us asking questions as well.
But that's a really good example, because I think there's two kinds of, like, if we look at the periodic table, there's sort of 3 kinds of questions, like, is that it? Well, no, we can add elements at the end, right? So where are we up to? We're up to an atomic weight of 120 or something. So yes, there could be one with 121. Let's try and find it. There's that kind of question, which is a good scientific question. Then there's the sensible sounding question that's actually nonsense. So, where do we go? Hydrogen, helium, beryllium, boron, carbon, oxygen, nitrogen. A perfectly sensible sounding question that one might ask is, well, what if there's something between oxygen and nitrogen? What if we could shimmy in Lintottium? Could go there, perhaps, just to give it a random name. But what's interesting about that is that that's a nonsense question, because to get Lintottium to exist, you'd need to throw out all of atomic theory and all of quantum physics, because we have this understanding of what an atom is, that it has an integer, it has a number of protons. That's what makes it an element. So Lintottium in this case would have 7.5 protons or something. What's half a proton? So in fact, there are good reasons from quantum physics why you can't have half a proton. So it's a sensible seeming question, but by asking it, I'm saying I'm going to disregard all of modern science. Now that doesn't mean it's not right. It just makes it a lot less likely to be right than the other kind of question. And so science here is about understanding which questions are worth working on. And so I think it's a really nice example that we can find this middle ground between we don't know anything, we're not done, and this is the received set of facts. And I think we're all very good as science communicators of living in that ground, and maybe less good at communicating. The third type of question, of course, is why is the periodic table like that? And then you've invented, 3 new branches of science, and that's essentially the history of 20th century chemistry. But maybe we'll save that for another podcast.
A couple of final things from me. You've written books alongside Sir Patrick Moore, but also Brian May as well in the past. And I think Brian May first, and then, of course, Brian Cox. They're 2 characters from the world of rock and roll who have got involved in science and are brilliant at it. And I think that crossover really in maybe the greater public's mind makes science more accessible, because I think actually maybe and also cool as well, because I think there probably was a time where it was men in tweed jackets on TV on Open University at 3:00 in the morning with long beards talking about space, and perhaps it got a bit, but when you see somebody like Brian May and Brian Cox latterly as well, it sort of shows, I think, actually, this is cool stuff, and you hear the things that they talk about with such passion as well, and the amount of work they've done on it, and realizing that it is wonderful, science, and of course it is all part of all of our lives. We are part of this whole cosmos just as much as everything else, and I think that really also introduces the public into this sphere as well. So it must have been great working with Brian.
Yeah, well, first let me say that the book I wrote with Brian and Patrick has been updated with Hannah Wakeford, who's the brilliant exoplanet scientist from Bristol who was on last month's Sky at Night. So bang, the complete and updated history of the cosmos is available, and I highly recommend that you go and read it. But yeah, of course it's fun. I mean, there's a tongue-in-cheek version of Brian, of course, which is that he started in astronomy, and so actually, if the story is that Brian's made rock and roll accessible to astronomers. And there are postdocs and PhD students all over the place who should be inspired by his example to go and
you can do it, guys. You can be the guy on stage.
Start your 30-year rock career. I have a very soft spot for an old friend, Stuart Clark, who maybe who's an author and a brilliant writer, but a long-haired amateur guitarist as well. And I was there when Stuart met Brian May for the first time, and Stuart said, Brian, I'm basically you, but I stayed in astronomy, which I thought was rather lovely. But yeah, of course it makes a difference. I think, and Brian Cox, of course, those TV shows, particularly the early Wonders programs, reached an enormous audience, and I think really gave people permission to be boggled by the universe, to break down the idea that it's about watching a clever man be clever. And there's touches of that in, the way Brian comes across and presents himself. But we're actually watching a clever man still be astounded by the universe. And that gives, I think, the viewer permission to be astounded by the universe. He's not there going, if you understood it, then you would know that, what it means to have a billion galaxies or whatever it is. I think it gives permission to people to be astounded. And the fact that he's playing stadium gigs, admittedly with Robin Ince, who's hugely important in sort of deflating Brian a bit and explaining to the audience what's going on. But the fact that they're selling out large venues to people to go and hear an evening of science is really, really inspirational. I think there's also a way lots of us, your listeners all are astronomers, I'm sure, whether that's people who go outside and look. Actually, my definition of astronomer has always been somebody who steps outside in an evening and instinctively looks up to see if it's clear. So if you're leaving the pub, do you look up or not? So by that criteria, I'm going to bet that most of your listeners are astronomers. And I think we all play that role of being the rock stars in our own communities. When there's something in the news, when JWST launched, I'm sure lots of your listeners got friends and family going, what's that new thing they've done then? Or, did they go to Mars again? And we get these questions. And so, in my case, there's a bunch of Torquay United fans who ping me whenever anything happens in space. And we divert from talking about our striking options to talking briefly about what the image is. And then they get distracted by the fact somebody's been sent off in the last match. But it's about having astronomy as part of our lives. Means we can bring it into to other people's lives as well. I was talking to... There's a wonderful astronomer called Michelle Bannister, who's a collaborator and a friend who's just moved back to her native New Zealand. And there they've just made a national holiday out of the Maori New Year, whose name I'm not going to remember, which is sad. But it's all about the point when the Pleiades is first seen rising. That's what starts the Maori calendar each year. And so suddenly there's a national holiday which involves going out and observing the sky. And Michelle was telling me that it's just wonderful because suddenly this is what she's always done for a living and as a hobby has become part of what everyone does for that brief period in the country. And so maybe we need the equivalent, but we could do that stuff in small ways. And both Bryans are really good at doing that, taking their astronomy and talking to their wide audiences about it, as well as other things.
The other question I think will be, it sort of links into that in some respects, though, is when you sat around the dinner table or whatever with people who maybe are or aren't involved in astronomy or in science or whatever, what's your kind of space fact or whatever that you dine out on that sort of blows people's minds? Because there's always something, isn't it? Did you realise that, somewhere in the universe there is a black hole that's bigger than our entire solar system? It's that kind of thing, isn't it? That the scale and the scope of space, I think, that really, people who don't really have a much of an understanding beyond the obvious, planets and solar system, that really makes them stop and think.
I think numbers are cheating. I think it's too easy to go, did you know there are 100 billion galaxies in the universe or whatever? Because and the reason it's cheating is because it gives the impression that I know what it means to have 100 billion galaxies in the universe. I've just got used to saying the number. I have no real understanding of that at all. I think my favourite, so I've got two, I think. My favourite is, I'm a big fan of Titan, which is this fascinating place, the moon of Saturn with the thick atmosphere and so on. And on Titan, it rains methane. But because of the gravity and the temperature, methane raindrops are the size of lawn tennis balls, and they fall slowly enough that you can dodge them. And I don't know why that appeals to me, but I think it suddenly gives you this sense of being in a really alien place.
That's what it sounds like to me.
That's
raining tennis balls.
Yeah, exactly. Yeah, smelly tennis balls. You see, it appeals to all ages. There's your 5-year-old interested. And then I think the other one I really like is the fact that we know the age of the universe more precisely than we know the age of the Earth. And depending on who I'm having dinner with, that's either because astronomers are better than geologists, but actually it's the idea that, there's this mind-bending idea that makes sense if you're a physicist, but doesn't otherwise, which is that the universe as a whole is really simple. That we can write down the equations governing the whole history of the universe on half a sheet of A4. It's only when you introduce chemistry and geology and gastrophysics and all the rest of it that it gets complicated. And so I am an astronomer who likes mess, which is why I study things like galaxy formation and interstellar objects and things that are the product of chemistry and so on. But I do like to think like a cosmologist occasionally. It's quite cleansing to believe that the universe is very simple. You could just write down 6 equations. The fact we don't know what dark energy is, well, we'll worry about that later. But I've got my beautiful equations. And so that, I think that sense is often quite distracted people. But really, I'm much more likely to drag people outside, get the 6-inch telescope out and try and make people look at Saturn, because that's the transformative thing.
Yeah, and what a wonderful thing to see, especially at this time of year as well, of course, at the moment. And I know that Kielder have been sharing images from their telescope too of, I think, all of the planets, actually, the other night, wasn't it? You managed to get them all.
Yeah, we did. All the planets. Actually, we did forget about Earth in all of this.
Yeah.
So we didn't look at Earth. We could have just taken a picture of the ground, but we didn't.
Yeah, it was noted.
That is definitely cheating. Yeah.
My little girl said, no, they've missed Earth. I said, well, yeah, but we're on Earth. You can't.
Yeah, you could do that one yourself.
So, yeah. Well, look, it's been fantastic chatting with you, Chris. And I know your book's been out a little while now, but your recent one, The Crowd and the Cosmos: Adventures in the Zooniverse, is available now. And, of course, people can help online with your research as well, can't they?
Absolutely. And watch. So the to-dos are buy a book, Crowd and Cosmos, or bang. Go and do my research for me, zooniverse.org, and put iPlayer on. And if you haven't watched The Last Guy at Night, which is about this JWST, I think it's a really special program. So ideally watch it. Alternatively, load iPlayer, press play, and walk away for half an hour, because we need the viewing figures. So those 3 things would be great. And I'm really looking forward to coming up to Kielder again. It's been way too long, and I hope I'll get up and see you as soon as possible.
It'll be great to see you. We've changed vastly since your last visit. We've got new buildings. We've got radio telescope, 5-meter radio telescope that we've got now, and all sorts. So it is a very different landscape to once you last came.
Nice. No, that's fun. I've just been reading. I've been working on some writing about the history of radio astronomy. So I'm deep in biographies about Grote Reber, who was the only radio astronomer in the world in the 30s and 40s, and I think he's become a bit of a hero of mine, partly because he only had one research job in his life, and one day he decided that he wasn't getting the support he needed, so he went to Hawaii on holiday and never came back. So there are other stories too. If you don't know about Grote Reber, have a look at Wikipedia. He's a fabulous character.
Our thanks to Chris Lintott for joining us in this month's episode of the Kielder Observatory podcast. And don't forget, you can keep up to date with everything happening at Kielder Observatory wherever you are in the meantime by heading on to social media and searching for Kielder Observatory on Facebook, Twitter and Instagram. We've got regular updates there of things that we've seen, things that have been going on at the observatory, and some other news from the observatory itself or from the wider space community too. So keep up to date with everything. Don't miss a thing between now and your next visit. And of course, to plan your next visit, head online to our website, kielderobservatory.org, where you can see all the available sessions for the coming months. And very soon, we'll have all the available sessions for the next year pretty much available to book. So keep your eyes peeled on that. Thanks very much for your company this month. Don't forget, check out some of our previous episodes, including the most recent one before this in July, where we spoke to a man called Jürgen Scholl, who's part of the James Webb Space Telescope project. Working at the University of Durham, a senior optical engineer, it was the University of Durham who provided some of the optics that are actually bringing us these fantastic images from deep in space. So its roots are very firmly in the northeast in many ways, and learn more about that project from a man involved in it and creating some of the technology behind it. We've also got fairly recent episodes as well where we're learning about space junk, about volcanoes in space, and also radio astronomy. Want to learn about all of those things? Head on to some of our previous episodes on any podcast app. And we'll be back in September for the next episode of the Kielder Observatory podcast. Thanks for listening, and we'll speak soon.